Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week, and we're going to be talking about the difference between weather and climate, and then we're going to go into normals, which are really a 30-year average, how those normals are actually calculated and how they can be interpreted and, in my opinion, misinterpreted in some circumstances. So that's the general topic for today. So let's take a look at a couple of very basic definitions of these two entities. Weather is the instantaneous state of the atmosphere at a specific location and time. So supposing you were to walk outside today and it was raining and the temperature was 50. That is the weather at that location at that particular instant in time. However, the climate is the average state of the atmosphere at a specific location over a much longer period of time, usually 30 years or more. So for instance, right now the normals are based on the 30-year period from 1991 to 2020. Once we get at the end of the year 2030, then the normals will be recalculated and they will go from 2001 to 2030. And those normals usually come out in the early part of the next year. So sometime in early 2031, we'll have a new set of normals to work with. But again, weather is the instantaneous conditions at a specific location. Climate is the long-term average. So what you're looking at here is a plot of the normal high temperature at RDU for every day of the year. That's the green line in the middle. And then the other lines, the three above it and the three below it, represent plus or minus 1, 2, and 3 standard deviations. And I'll talk more about what that actually means in just a second. But you may notice that in the summer months, those lines are more tightly packed than they are in the winter months. And that basically is telling us that the range of possibilities in the winter is almost double what it is in the summertime. And that's because the temperature gradient across North America is much tighter, much more significant, if you will. Like, for instance, in January, it may be 20 below zero in Minnesota and in the 60s or 70s in South Texas. And so you have a big temperature gradient there. And if the wind starts to blow from the north or the south, then you can get some big swings from one day to the next. In the summertime, it could be in the 90s in South Texas and the 80s in Minnesota, and it doesn't matter what direction the wind blows from, the difference or the change is not going to be all that big. So that certainly points that out in a graphical manner there. Now, these are the actual numbers that made up that graph that you just saw there. And let's just take January 1st, for example. So the mean is 52.0. That's the quote-unquote normal high. And then on the cold side of that, one standard deviation takes you to 41.2, 2 to 30.4, 3 to 19.6. And then on the warm side, 62.8, 73.6, and 84.4. And so one of the things that I always thought would have been helpful, but just could never either figure out a nice way to display it or to get enough people to buy into it, is that to say that there is a specific normal high for a date, to me, is ridiculous, because every year is different. I mean, when's the last time that if you've been living in Raleigh for 30 years, has the high temperature on every January 1st for the last 30 years been the same? No. Okay, the atmosphere is dynamic. It changes from one year to the next. And so why not talk about a normal range for a given date? And I'll talk a little bit more about that in a second. But you can see there that 3 standard deviations is 107.1 in August, and we've never experienced that. The highest temperature ever observed at RDU is 106. That was this past summer. And of course, I have serious doubts about the reliability of that number, but that's another topic for another day. And then on the cold side, you have a 19.6 on January 1st, and the coldest high temperature ever observed at RDU is 17. Now, here is, again, reiterating what I just talked about a little bit ago, is that the range on January 1st is 64.8 degrees from -3 standard deviations to +3, while in July it is only about half that, 33. So again, the weather can be much more have a much greater range of possibilities in the winter months as opposed to the summer. Now, what I did here was I took the actual highs, and when they compute the normals, they do some averaging and some rounding and some spline functions and all this sort of stuff, because if you actually took the raw numbers, you'd get sort of a zigzag line, and so they want to smooth that out so that you have a nice gradual change going up from winter to summer and down from summer to winter. But what I did here was I actually took the actual highs on January 1st from 1991 to 2020 and plotted your classic little bell curve here. All right, so the mean out of all those 30 high temperatures was 53.9. Now, if you take plus or minus one standard deviation, which means that 68% of the data points underneath that curve are going to be in that green area that you see there, and that ranges from 43.4 to 64.5. Now, that's a pretty big range, and so I wouldn't want to say that on January 1st the normal range would be greater than 20 degrees, which is what it is there. But let's say we take half a standard deviation, and that would probably put us at about 48 to 59. So you could make the argument that on January 1st, anything between 48 and 59 is normal for that date. And again, if you hear somebody say, oh, well, the normal high is 54 and we were 56 today, that's 2 degrees above normal. Big deal, okay? It's well within what I would call the normal range for that specific date. And so anyways, 68% of the data falls between 43.4 and 64.5. Now, if you go plus or minus 2 standard deviations, now you're going from 32.8 to 75.1. And so that represents 95% of the data underneath that curve, okay? And then if you go plus or minus 3 standard deviations, 99.7% of the data is going to fall between 22.2 and 85.7. Now, if you look real carefully, and hopefully your eyes are better than mine, you might notice a little red area on each tail of the bell curve, way to the left and way to the right. So that little red area would represent the 0.3%, the true outliers, if you will, that would be very unlikely, but statistically still possible, okay? So the red areas represent 0.3%. Everything else, the tan, the yellow, and the green, represent 99.7% of all of the data points that existed within that particular 30-year period on the 1st of January. So again, this just gives you an idea as to what the climate can be like. The climate varies, and when you average out all those possibilities, that's what makes up the normal. But again, it doesn't make sense to me to have a specific number for that normal. A normal range seems to make much, much more sense. And who knows, maybe if I can automate a graphic like this, maybe I can actually show that on the daily update so that we can implement that idea, even if no one else in the world does it. You know, what the heck? It's always fun to be different, right? Sometimes being different can be good, sometimes being different can be bad. But anyway. All right, so that is bonus weather video number 3 for this week. The next one will be coming up Monday, and the next daily update, of course, coming up later this afternoon. So I hope to see you then. In the meantime, have a wonderful Friday, and we'll talk to you soon. Take care, everybody.